Hello everyone. I want to welcome you to today's presentation I titled Direct Treatment of Sewage/Wastewater for Reuse. My name is Omede Maxwell. I'm a water quality and environmental expert from Department of Physics, Environmental Geophysics Option, Covenant University, Ogun State, Nigeria. These are my email addresses. Considering our teaching series we had earlier on groundwater treatment for bottled water production, followed by surface water treatment for bottled water production. Thereafter, we had innovative and indirect treatment of surface water for public use. Today, we are going to look at direct treatment of sewage/wastewater for public reuse. This is the source of the wastewater we're going to use to explain the procedures on how to treat it. You can see cloths, you can see tissue papers, you can see rubbish everywhere. So we source the water from this point. This is intake of wastewater into this designed large storage tank. From this designed large storage tank, the water comes into screening chamber. From this screening chamber, it is partitioned into two. We have coax screen that removes larger rubbish as well as toilet papers that are large. From here, it will move into fine screen that removes other finer rubbish and toilet tissues. After the screening chamber, the wastewater will flow into the grit chamber that removes debris. After this grit chamber, the wastewater will enter into the skimming tank. This skimming tank has an inbuilt separator. This separator uses tiny pore spaced belts to resist the passage of waste materials. After this skimming tank, the water will move into the primary clarifier for sedimentation to take place. From this primary clarifier, it reduces the organic load that would have been moved to this aeration tank or this secondary treatment tank. So from this point, the organic load will have been removed with the help of primary clarifier and sediment it down this point, which the sludge will now pass through. When this valve is open, it will pass through this valve into this disposal point. So the sludge will be disposed at this point. Thereafter, you close this valve, the sewage water will now flow through this point into the aeration tank. From this aeration tank, the sewage water comes in contact with oxygen. The oxygen will oxidize iron and manganese. To oxidize iron and manganese from this point. And another thing that happens here is that organic constituents such as phosphate can be removed by bacterial process, since the sewage water contains E. coli and other pathogens. So, because of the oxygen content in the water here, it will make favorable growth that will enhance degradation of organic matter by the bacterial processes. These bacterial processes that take place here with the oxidation, the process handles 70 to 75% of the organic matter within an hour. Thereafter, the water is pumped into this secondary treatment tank. From this secondary treatment tank, those chemicals such as iron trichloride This iron trichloride serves as a coagulant. It will assemble other organic matter in the wastewater and removes them as sludge. This erection tank here would have removed suspended particles, other organic matter, and as well remove dissolved gases and oxidized bioxygen demand. At the end of the day, this tank will serve as a separation of biological sludge and as well create effluent quality of more than 80%. So within this secondary clarifier, it separates biological sludge as well, which will now flow through this way. The sludge will flow through this way, come to this point, and as well disposed here. That's why here we put it combined primary and secondary sludge disposal points. After such is disposed here, the water will now flow and come into this rapid sand filter. The rapid sand filter will handle the oxidized iron and manganese. It will remove it here because it will cause it will have been turbid here. Then this rapid sand filter will remove turbidity. Then after the removal of turbidity, the water will now flow and comes into activated carbon filter. From this activated carbon filter, it will handle micropollutants, which none of these handled it. After handling micropollutants, it will as well remove residual iron trichloride and it will remove color, taste, and odor. After the activated carbon perform its activities, the water will flow into this disinfection chamber. From this disinfection chamber, we prefer chlorine to be used as the disinfectant. The reason is that if ozone is used here, any slightest exposure will turn O3 to O2, which will make favorable condition for growth to come up. So in that case, we choose chlorine. So the residual chlorine that will take the water for a very long time will be dosed here according to chlorine demand. So if it is dosed here, this water will now serve as treated water for public reuse. So this is the distribution system to the distribution point where it can be sent to the public for reuse. You can now see the standard operation procedure for sewage water treatment. That's for direct method. By next week, we shall be taking you through the innovative and indirect method of sewage water treatment. Thanks for your attention.